This topic, old syllabus is topic 3 lah. The new syllabus is topic 2. And projectile motion, non-linear motion lah. Right? Make sure you know how to derive the maximum height, time of flight, range, and the straightforward derivation. The projectile projected at velocity u at an angle theta. The horizontal component is u cos theta. Right? Horizontally is uniform velocity. Vertically is u sin theta, uniform acceleration. Right? If we throw a ball horizontally from the cliff, that is your cliff. Right? We can think of it as two types of motion. One is horizontal motion, uniform velocity. The other one is vertical motion, uniform acceleration. So at any time, you just combine the one with the same time, like the blue one and the blue one, combine to get the resultant direction, resultant velocity. I think the motion and combination of uniform velocity and uniform velocity horizontally and uniform acceleration downwards from the rest. And anytime we combine the two motion independently as vectors to find the velocity. Right? Effect of air resistance. Right? Vertical height is lower because vertical motion there is more resistance, more deceleration. And when it come down, right? So the maximum vertical motion, there is more deceleration, so the vertical height is going to be lower. Horizontal motion is subjected to deceleration because of air resistance. Normal uniform velocity, the speed decreases, the range will be shorter, the trajectory, that's the trajectory, ideal path. Right? No air resistance is symmetrical about here, right? From the middle here, at the maximum height there. But when air resistance is not negligible, then it's not more symmetrical. Right? It can be vertical downwards, depend on whether it has reached terminal velocity or it has zero velocity horizontally. Okay, downwards, there's air resistance and there's your weight. So it's normal G, right? It's going to be less than G. Okay. We have solved this one. See whether you can remember. What's the answer for this one? A football is released above a plane sloping surface and bounced several times. The diagram shows the path between the bounce at X and Y. Assuming there is no air resistance, what is the graph? Which of the following graph correctly shows the variation with time t of the horizontal component of velocity VH between X and Y? Yep. And remember, you are on
D.
what answer is your answer?
D.
B, okay, good. If it's vertical component, it's D lah. Okay, how about this one? Projectile is fired at an angle alpha to the horizontal at a speed u as shown. What will be the vertical horizontal component of velocity at time t, assuming air resistance is negligible and the acceleration of free fall is g? Yep.
U sin A.
Answer?
A.
No,
Oh, wait.
after a time t, not initially. Initially, you're right. But after a time t, horizontal doesn't change, stay constant. Only vertical is uniform acceleration. Uniform.
Let's see.
Yep. Right. U sin theta, U cos theta. Horizontal component constant. Right. U cos theta. Vertical component. Vertical motion. That's a uy. U sin alpha. Taking outwards as positive, you get minus g. So you want at time t, what is the velocity? Choose the right information. Okay, good. How about this one? This horizontal motion, horizontal velocity that you want to find. A motorcycle stunt rider moving horizontally takes off from a point 1.2 meter above the ground, landing at 10 meter away as shown in the diagram. What is the speed at takeoff? Can find the vertical time. Vertical.
Um,
Here we want to determine the horizontal component of velocity. We have the distance, but we need to determine the time of flight. That's the first thing. So consider vertical motion first. So that one, determine the time of flight. Consider vertical motion. Take downwards as positive. Vertical motion initially, the picture is a bit deceiving now. It shows you at an angle, but it's actually horizontal. Right? Yeah, told moving horizontally. So u equals to 0. Vertical motion, acceleration. For objective one, you can use 10 now because you want to do fast mentally if you can. And the height is 1.25. Choose the right formula to use. Calculate out 0.5. Right? Determine the horizontal velocity. You got 10 meter. So horizontal component is distance divided by time. Distance is 10 divided by 0.5. So it's 20 meter per second. Answer donkey. Can?
yep.
How about this one? A projectile is launched at O. That's your O. Follows the path O, P, Q, R, S. As shown, air resistance is neglected. Which statement is true for the projectile when it's at the highest point Q?
C.
C, is it?
Yeah.
No,
Wait, but I thought highest.
highest point Q.
Oh,
Vertical velocity is 0. Horizontal velocity is not 0.
yeah.
Remember that. It still got horizontal velocity. Only vertical velocity is 0. A.
Wait, teacher, why is it not C? I thought highest gravitational potential energy means zero kinetic energy.
No, no, it still got horizontal component of velocity. So it still got kinetic energy.
Oh, okay.
Okay?
Oh, because it's not because it's okay. But if it's like because it's moving, right? It's moving
It's moving.
horizontally, but in vertical, like let's say zero
Vertical one is
uh
0. Vertical one at Q is 0. But horizontally, it's still always constant. Never disappear.
hmm,
Okay?
okay.
Because you neglect air resistance, it's always there. Since the horizontal component of velocity is not 0, kinetic energy is not 0. Likewise, momentum is not zero, but horizontal at Q. Question, at which point is the vertical acceleration zero? At which point is the vertical acceleration zero?
Q.
No? Acceleration distance disappear. It's always there. This is a trick question.
Oh,
G never go to zero. It's always there. Only the vertical velocity goes to zero. Okay?
yeah.
Try this one. A bit more tricky. Projectile is launched at 45 degrees to the horizontal with an initial kinetic energy E. Assuming air resistance to be negligible, what will be the kinetic energy of projectile when it reaches the highest point?
Consider vertical component.
Yeah, what's the answer? Basically, you're trying to find the horizontal component, that's all. At the highest point, it's a horizontal component only.
Highest point, so A equals 0.
Let the speed of projection be V, because you got kinetic energy given. So let it be V. E equals half mv squared. Right? And subject V to E divided by m square root. Right? So that's the velocity of projection. Then you want Ux. Ux equals to V cos 45. So V is that one. Cos 45 is 1 over root 2. Root 2 and root 2 cancel is square root of E over m. At the highest point, horizontal component of velocity Ux is not zero. Right? It's Ek half mux squared. Right? Ux we already found. So half m square, this one is E over m. M and n cancel. So E over 2. Answer A. Okay or not?
Right.
Okay, let's try 2 more questions. A ball is thrown horizontally in still air from the top of a tall, very tall building. The ball is affected by air resistance. What happened to the horizontal and vertical component of the ball's velocity? What's your answer?
Horizontal component.
There's air resistance. Yep.
Remains constant, right?
No, air resistance is not negligible. So horizontal component will be affected. It will decrease. Whereas vertical component also affected.
Increases to a constant value.
Yep.
Because terminal velocity, right?
What's the answer?
B.
We can think as a motion of independent vertical and horizontal motion. Thus, both motion will be affected by air resistance. Right? Vertical motion and horizontal motion affected by air resistance. Horizontal component velocity will decrease to zero, while the vertical component will increase to a maximum constant. Right? This is thrown from horizontally from a tall building. So vertically it's dropping. So the vertical velocity will increase at not constant rate until it become constant. No? Will increase to a maximum constant velocity called terminal velocity. The answer is B. Okay?
Yep. But teacher,
Yeah.
uh, the the force with air resistance is called drag force, right?
When it's walking down, the force acting will be downwards will be your weight, upwards will be air resistance. No?
Is air resistance and drag force the same?
Say again.
Uh, 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 drag force and air resistance is the same thing.
Same thing, same thing. Any more question?
Oh, no.
Okay, let's try another one. This one, the golf ball hit with the same force and direction on Earth and on Moon. Which diagram best represent the shape of the path taken by the golf ball?
B,
Say again.
B.
No, no air resistance on the Moon. G is smaller, so the ball will spend more time above the ground, so it will move further than on Earth. On Moon, there is no air resistance, so no air resistance. There's no air resistance, no air resistance negligible. The answer is C. Lo. Can
Wait, uh,
Earth
why is B or A wrong?
cannot be A because on Moon there's no air resistance, so it should be
Oh,
symmetrical.
okay, okay.
Okay, let's do some paper 2 question. Let's try number 16. A ball is thrown horizontally from the top of a building as shown in figure 2.1. The ball is thrown with a horizontal speed 8.2 meter per second. The side of the building is vertical at point P on the path of the ball. The ball is the distance x from the building and is moving at an angle of 60 degrees to the horizontal. Air resistance is negligible. For the ball at point P, show that the vertical component of velocity is 14.2. How am I going to do that?
Uh, solve a vertical component.
Say again,
You have to resolve the vertical component, right?
there is no vertical component given you. You are given only horizontal component.
Oh, start by finding the time.
How to find the time? You got no height. The tree is looking at here. Redrawing the diagram. Horizontal velocity is given. 60 degrees is given. So calculate the vertical component now. This particular
Oh,
state.
yeah.
Right? Horizontal component of velocity remains at 8.2, no air resistance. So we use tangent. Right? Tangent V, tangent 60 is V over 8.2. And calculate. No? Determine the vertical distance through which the ball has fallen. What's your answer? Testing you using the
Find
formula for
find the
uniform acceleration, that's all. Right? Consider vertical motion, no? Taking downwards as positive. U equals to 0. A is 9.81. V is 14.2. We have calculated. So you want to find S. Choose your V square equals U square plus 2AS. Put the value inside. Calculate your S. Okay or not?
yeah.
Determine the horizontal distance X. Yep. How to do that?
Horizontal distance X.
Hmm.
Finding the time.
Find the vertical time first. Consider vertical motion. Time of descent. Taking downwards as positive as usual. Write down what is given. U equals 0. 9.81. V is 14.2. And choose the right formula to use. Calculate the time. Then from there, can calculate the distance. Uniform velocity horizontally. Right? Speed is distance over time. So distance is speed times time. Okay or not?
Yep.
Okay. The path of the ball at A in A with the initial horizontal speed of 8.2 are shown in the diagram figure 2.2. On figure 2.2, sketch the new path of the ball for a ball moving at having a horizontal speed greater than 8.2 with negligible air resistance. Label this G. Where should it be? Yep. No air resistance. Greater horizontal speed. Where should the graph be? Further away or shorter distance?
If it has an initial horizontal speed, right, it should be further away.
Greater. So it should be
Yeah.
further away, no? The curve should be further away. Same shape. Equal to 8.2, but air resistant. With air resistant, now where should it be?
Uh, like it'll drop behind the first one.
The distance, no? Okay.
Yep.
Okay. Let us try other question. Try this one. A ball is thrown against a vertical wall. The path of the ball is shown figure 3.1. Not to scale. The ball is thrown from S. That's your S. With an initial velocity of 15 meters per second and an angle of 60 degrees to the horizontal, assuming air is resistant and negligible. For the ball at S, calculate the horizontal component of velocity. Okay, this one is to give you easy mark. Horizontal component,
Uh, 15 cos 60.
okay, good. Calculate out. Two significant figure or three significant, good enough. Vertical component of velocity,
15 sin 60.
That's all. Right, you want to put 13.0 also can. Okay, now more challenging now. Make it think a little bit more. Horizontal distance from S is 9.95. Right? That distance is 9.95. The ball hits the wall at P with a velocity at right angle to the wall. The ball rebounds to a point F that is 6.1 meter from the wall. Using the answer in A, calculate the vertical height gained by the ball when it travels from S to P. How am I going to do that?
Finding the time.
How do you find the time?
V equals U plus AT.
Use that distance, no? Right?
No,
In all the horizontal component calculated, this part, velocity is 0, vertical velocity is 0, because your toe is 90 degrees. You got 10 more minutes. Taking outwards as positive, consider vertical motion. Right? Ux is 13, V equals 0, A is minus 9.81, S equals to H. Right? Substitute in the formula, 8.61 meter.
it's a negative 9.81 because it's going up, right?
It's going upwards, we take outwards as positive. A is downwards.
Oh,
Okay or not?
yep.
Show that the time taken for the ball to travel from S to P is 1.33. Yep. How to do that?
Use the H you obtain and sub inside the formula to find T.
And use the H sub inside there to find T. Can use that, but easier to use horizontal component.
Horizontal.
Horizontal component faster. Show that the velocity of the ball immediately after rebounds from the wall is 4.6.
So it's a momentum thing, is it?
No, it doesn't bring in momentum. It asks you to
Or
show that the velocity immediately after rebound is about 4.6. Yep. Right. It is from the same height. So the
same height.
time taken is same. Horizontal distance is given. So from there, you can calculate. Consider horizontal motion. Since the ball hit the wall at right angle, it's reflected at right angle. Consider horizontal motion. Time taken to travel from S to P equals to time taken to travel from P to F. Right? Horizontal component, X equals to UX times T. So put in your value. Calculate your UX. Okay now?
Oh,
Anything not clear?
yeah, okay.
Okay, let's try one more question. Hopefully we have the time to do that. Oh, haven't yet. Mass of the ball, they try to include two or more questions. They try to include two or more topics in one question. So they say, once you got 11 topics, how to cover all of them? A ball of mass, this one, calculate the change in momentum when the ball is rebound from the wall. Right? Make sure you know how to calculate that. What is your answer?
Uh,
Usually they are not interested in direction, magnitude only. Right? Go into the formula, change in momentum, NV minus U, mass, right? Given kilogram. Right? You take this to the right as positive, to the left is negative, so it's minus, we get negative sign. It doesn't matter whether you put negative there or not. It won't penalize you, but you should get 0.73 Newton second. Can
yep.
state and explain whether the collision is elastic or inelastic.
Inelastic.
Okay.
Inelastic.
Why?
Total momentum is not conserved
How do you know?
because
How do you know?
there's a change in momentum.
We when it's elastic or inelastic, we don't look at momentum. We look at kinetic energy.
Okay.
Initial and final kinetic energy must be the same. But here is different. Right? From the speed, we can see that the kinetic energy is going to be different.
Slower, becomes slower.
Ah, okay.
Wait,
Any
teacher, I
comment?
think you can say total momentum is not conserved also.
Momentum is conserved. In a collision, momentum is conserved. Okay, no? Momentum is conserved.
I thought it's conserved for elastic
No, no,
collision.
no. Momentum is conserved whether it's elastic or inelastic.
Oh shit. Okay.
Only kinetic energy is not conserved. But don't use the word conserve. Right? Kinetic energy after collision is less than before collision. Okay.
I think I wrote that for exam today. Oh no.
Say again.
I think I wrote that for my exam.
I say you are not ready yet. Right. We will try number 15. We won't have time to solve it out. For about three minutes left. A small ball is thrown horizontally with a speed of 4 meters per second. It falls through a vertical height 1.96 before bouncing off a horizontal plate. That's a plate. Air resistance is negligible. For the ball, as it hits the horizontal plate, state the magnitude of the horizontal component of velocity. Yep. What's the horizontal component of velocity when it hits the plate? Yep.
Uh,
Yep.
45. 45.
Why you say 45?
Wait, they didn't give an angle though.
Doesn't matter if you hit at an angle, horizontal component is always the same. No air resistance. Okay now.
Oh yeah.
Show that the vertical component is of the velocity is 6.2. How to show that? Yep. How to show that?
Finding the time first.
Conserve vertical motion. No? Initially, it's drop. U equals 0. A is 9.81. You take downwards as positive. Then the height is given. Then choose the right formula. Put in the formula and then calculate out. Right? Cannot use G as 10. It's 9.81.
Yeah.
You will lose a mark. That means your answer is wrong. You will gain some mark. The component of velocity in A are both vectors. Complete 3.2 to draw a vector diagram to scale, determine the velocity of the ball as it hits the horizontal plane. Right? That one drawn for you already, horizontal component drawn to scale. You have to choose a scale. Right? Scale 1 cm, represent 1 meter per second. Right? You should get 10.4. Just draw for 4.0 cm, then 6.2, and complete the rectangle. Yep. You cannot calculate. Calculate, you won't get full mark. Okay? Measure.
Wait, teacher, can I see that again? Why they suddenly use tan? I haven't seen a question using tangent.
Say again.
Wait, I want to see the previous, the
Oh,
tangent one.
we will get cut off already lah.
Oh,
You go to motion, linear motion. After this, you can try some of the question there while you wait.
Sure, is there a
Okay.
limit for the Zoom?
Say again.
Is there a limit for Zoom